Hello, everybody. Today we're going to be talking about the DEF system on the 2019 Silverado F 1500 with the 3-liter Duramax on the dyno. So my name is Jacob Kawika.
And my name is Lucas Schreiner.
All right, so we're going to start off really simple and basic. To start off, we're going to do your initial fill. So you come to your gas cap on the driver's side of the vehicle. Your DEF is clearly labeled, as well as your green for your diesel fluid. As most diesel fill-up stations, you have a green pump. So we're going to start out from our initial fill, which is going to then drop down into the DEF tank. You can see this line right here. So that line is actually the feed line to the injector. Goes off a little bit into the distance, and you'll see it come around right here, follows the frame of the truck, heads towards the front of the vehicle. Continuation of it, this line is separate. You can see a little bit back there of it, moves up, follows along here, and eventually crawls its way up into the engine bay, and directly into the injector, which is what this is. And we do have two coolant lines going into it, as well as our electrical connector. So moving on from the basics, we'll talk a little bit about the description and operation of the DEF system. So to start off with, this includes a DEF injector, the DEF tank, reductant control module, reductant level sensor, reductant pressure sensor, and a reductant pump. So the DEF is first moved from the tank after you fill it up directly into the injector. Like we don't have any filters or any kind of breaks in the hose, no nothing. It's just a straight line directly to the injector. And it's moved via a pump, which is located directly inside the tank, which when reading the PIDs, we found that the average of 72.5 psi was desired. Obviously, did not maintain that the entire time, especially when it was off. The reductant control module varies the duty cycle of the pump voltage to maintain the reductant pressure within that desired 72.5 psi. The PCM is what actually controls the amount of reductant released by the injector, and it does this by reading the NOx levels from all three of the NOx sensors, which will go over the three locations and tell you why this is significant in this case. And something kind of cool is when the ignition is turned off, the reductant pump is run in reverse for about 45 seconds in order to drain the supply line of all the DEF fluid so it doesn't freeze. And during this process, the DEF injector is hung open. So our initial issue was that we wanted to do and go and dig deeper into an event called ammonia slip. So ammonia slip is basically where the DEF injector is spraying more DEF than needed, which causes ammonia to slip past the ammonia slip catalyst, which is all the way in the end, which will show you a diagram of how all that works. And it ends up making its way into the atmosphere, which can be harmful. Now, NOx sensors are not able to differentiate NOx and ammonia when reading certain levels, so this can cause an issue. The best way to diagnose this would be check NOx levels, especially on sensor 2, and we'll show you the locations, like I said, and why this is significant. But they would read higher NOx levels than actually is because there is also a NOx sensor directly from the turbo. So obviously, if you're reading higher than that, you got an issue, and more than likely it's ammonia slip. Now, ammonia slip is usually kept within a range of 2 to 10 parts per million, but occasionally it can get out of that range and it can cause some issues in the vehicle. So we didn't do this just because ammonia slip can be a pretty serious issue, especially when you're dumping a lot. It's harmful to breathe in a lab environment. It just could pose a little bit of a risk, especially considering that the smell of all the diesels running is already bad enough. Another issue is that ammonia slip is actually pretty tricky to replicate without causing any actual damage, because with too much ammonia in the system, it'll eventually crystallize, and when it crystallizes, it's a little more difficult to burn off, and there's more than it can burn off because the vehicle's spraying too much. so that can cause an issue in the exhaust system. And due to not being able to replicate this, it is still a real world issue. So we will be discussing some hypothetical diagnostics and symptoms of ammonia slip in scenarios you might encounter in the shop.
Yeah, so since we had to rule ammonia slip out of our project, we started with a couple different ideas, just kind of mess around with what could possibly go wrong with the DEF injector. We started with an electrical fault here. For our test, we just unplugged the electrical connector to the DEF injector. It's a 2-wire connector. The harness runs directly from the connector to the PCM, nothing fancy. Unplugging this could also be replicated in the real world cases being rodent damage, anything that could open one of those 2 wires. They do the same thing. We got one DTC P2047, as you can see in the bottom, just saying that the reductant injection valve circuit is open. We got 2 dash lights, check engine light to go with that DTC, as well as the light you can see there in the middle right, which is actually the DEF warning light, as well as 3 warning messages on the dash, being service exhaust fluid system, 99 miles until 65 mile per hour max speed, which is just saying if you don't get this fixed, we're going to put you in limp mode because tampering with after treatment is both illegal and harmful to the environment, as well as see owner's manual now. What we took from this, basically that there was an open and it created a DTC because PCM understood that there was an electrical fault, and then you can take that DTC and plug it into all data or GM service information and get your diagnostic procedure that way. Or pretty simple way of diagnosing it, since it is an electrical issue. Obviously you'll have that check engine light as well as the DEF warning light. So the first thing you do is take your scan tool, check for DTCs. After you take your initial DTC and understand what's wrong with the system, then you got to figure out why. Since your scan tool's already plugged in, the easiest thing to go to next would just be observing live data operation or lack thereof. Under perfect conditions, you're going to see injector operation on your scan tool. If you don't, obviously, then that confirms that there's an issue with the wiring harness or the injector or the PCM. It's a very simple electrical system. You've got 3 possible breaks here. So the easiest thing to start with would be the harness itself. Since it's just a 2-wire harness, you verify continuity on each of those wires with key off, engine off, just making sure that both of those wires are intact. If they are, next easiest thing would be the injector itself to make sure that the resistance with the harness unplugged matches whatever OEM specification depending on what manufacturer vehicle you're working on. And if the harness is good and the injector is good, it has to be a PCM issue. So, resetting the vehicle between faults, we plugged the connector back in, cleared the code, and our DEF warning light wouldn't go off. Cycled the key, actually turned the engine off completely, turned it back on completely, turned it off, put it in accessory mode, put it in key on, engine off. Nothing. Nothing would turn this light off. We had to turn the vehicle on, get it up to operating temperature, and basically cycle it between 3000 RPM and idle, just trying to get it to understand that, hey, the circuit's good now, and the PCM can understand that it can now re-inject DEF fluid into the system and see the changes on the NOx sensors, and then it turns the light off. So first we messed with the electrical side of the system, and second scenario here we went for more of a physical fault we disconnected the DEF line that comes straight from the tank in the back to the injector. The electrical system was left intact, so the PCM is still trying to open the injector, and the pump is still pumping DEF fluid from the tank. So we dropped that hose down through the wheel well into a waste container, and Jake was so gracious to lay on the floor with PPE and make sure that that didn't spill all over the place. We did get one code from this, as you can see there in the bottom, P249C, excessive time to enter closed loop, basically saying, hey, I can tell that there's something wrong with this system physically, even though it was operating electrically perfectly fine. Now, desired pressure versus actual, as Jake mentioned before, the desired pressure for this system is about 72.5 psi, and we verified that with the scan tool data, both under normal operations and faulted operations. However, under faulted operations, the actual pressure was reading about 55 psi. So that sensor is most likely closer to the tank, because in Jake's personal experience, making sure that all the DEF fluid ended up in the waste container and not all over the floor crystallizing, he only got a trickle on the end of that hose. So it was definitely not 55 psi at the very end. It does take a lot of volume to push 55 psi all the way up to the front of the truck and hose that thick. So we didn't really get that much pressure at the end. This fault could also look like an AC drain issue for that reason exactly. DEF fluid being clear, not getting a lot of fluid trickling out because the pump doesn't push that much volume. It could very easily look like a car is just dripping AC water in the parking lot. Now, under normal operations, as you can see in the top here, I have the scan tool data pulled up, and kind of in the bottom of that picture, we have all three NOx sensors. Under normal operation, NOx sensor 1 would be reading anywhere from about 60 to 240 parts per million, and NOx sensors 2 and 3 would read 0. 2 mostly 0, 3 almost certainly 0, because the aftertreatment system is doing its job. As you can see here, under faulted conditions, NOx sensor 1 is reading 0 parts per million, and NOx sensor 2 is reading 71.4 parts per million. So I'm going to let Mr. Gill pause the video here and kind of throw a bone to the class as to why they think that is.
Something also I wanted to include is we do have a video of the actual pressure coming out, so we'll include that into the video, so you'll see that in a second. So as I was just talking about, we had the vehicle running at about 2500 RPM, and as you can see, we were only getting dribbles out, whereas the pump was reading about 52 PSI. Okay, so moving on from the video, we're going to move over to hypothetical scenarios. Basically, I drew up a little diagram here, found a nice picture. Got our NOx sensors that are labeled in green. We got 1, 2, and 3. This is our close coupled DPF system. And then we have our farther. So with our DEF injector on terms of ammonia slip, right? So let's say hypothetically this DEF injector is hung open. And as I talked about previously, with sensor 2 NOx emissions reading a little higher, as these sensors actually can't tell the difference between NOx emissions and the ammonia. If this injector ever gets stuck open, or it's feeding too much somehow electrically, or this sensor is even reading wrong on its own, causing this to dump even more, obviously you're going to see a spike in the sensor 2 emissions compared to sensor 1, even though sensor 1 is before any of the emissions are happening. So this is directly out of the exhaust. So you're going to know you have an issue with something going on in here, either the DEF injector putting too much out, or the SCRF not doing its job, causing your emissions levels to be a lot higher here at number 2. So that's kind of a telltale sign for your ammonia slip. And all these little bullet points I have over here are more so indirect causes of your ammonia slip. And obviously with our other fault that we created, we did see the service emission system message displayed, which is expected. But with ammonia slip, GM does try to combat it a little bit with the ammonia slip catalyst here all the way at the end, which does a pretty good job of keeping the levels within that 2 to 10 parts per million, which I discussed.
Yeah, so to bring it home here, ammonia slip is common, but it's also very regulated, and purposely recreating it is illegal, as Jake found out in his research for this project. The electrical failure that we replicated within the DEF injection system will produce codes, warning lights, and put you in limp mode if not fixed quick enough. And the hydraulic failure that we put in scenario 2 will also produce a code, but the diagnostic process for that is more reliant on visual diagnosis as opposed to the computer diag.